Audio Jungle. Audio Jungle.
Understand decibel, dBW and dBm in power measurement. Define dB, dBW and dBm. The other common term used synonymously for optical attenuation. Optical loss attenuation is measured in decibels or dB. Attenuation, also known as the reduction of the optical signal intensity over a length of optical fiber or components. Attenuation, or loss, is normally measured in two instances. Fiber attenuation is normally measured per unit length in decibels per kilometer, decibel per kilometer, which due to absorption and scattering. Individual component attenuation, in dB loss for splitters, couplers, WDMs, connectors, both mechanical and fusion splices, etc. The units used for measuring attenuation of optical cables and sensitivity of photodetectors. dB, decibel. dBm, decibel reference to 1 milliwatt. dB is a relative unit that represents a ratio. dBm is an absolute unit that is referenced to 1 milliwatt. The unit dBm is devised because in practice, 1 milliwatt is a convenient reference point from which to measure power. dBm is considered as an absolute unit, a unit to measure power. Define. Attenuation in fiber optic, also known as transmission loss, is the reduction in intensity and amplitude of the light beam or signal with respect to distance traveled through a transmission medium. It measures the amount of light lost between input and output. Is defined as the ratio of optical input power to the optical output power. The attenuation wavelength curve and the transmission windows of an optical fiber. Infrared light with wavelengths of 850 nanometers, 1310 nanometers and 1550 nanometers is mostly used. Therefore, the most common devices used as the light source in optical transmitters are the light-emitting diode LED and the laser diode LD. They operate in the infrared radiation 750 nanometers to 1 millimeter of the electromagnetic spectrum, so that their light output is usually invisible to the human eye. 4.2 Apply decibel, dBW and dBm in power measurement problems. Solve given problems related to power measurement calculation. .3.1 Expose insertion and return loss. Use the appropriate formula. Insertion loss refers to the fiber optic light loss caused when a fiber optic component inserted into another one to form the fiber optic link. Insertion loss can result from absorption, misalignment or air gap between the fiber optic components. We want the insertion loss to be as less as possible. Our fiber optic component's insertion loss is less than 0.2 decibels typical, less than 0.1 decibels types available on request. Return loss is the fiber optic light gets reflected back at the connection point. The higher the return losses means the lower reflection and the better the connection is. According to industry standard Ultra-PC polished fiber optic connectors, return loss should be more than 50 decibels, angle polished generally return loss is more than 60 decibels, PC type should be more than 40 decibels. Insertion loss yield. 1. Coupling loss. Some of the common causes are diameter core mismatch. 2. Cable that couple connected must have the same diameter of the core and cable. The mismatch of core and cable diameter will affect the light propagation. Longitudinal misalignment. This loss is also known as the separation of the fiber end. the light propagate outside the core and affected the light transmission. Lateral misalignment. The fiber laterally misaligned and the light may be refracted or reflected outside the fiber core. Angular misalignment. The fiber is placed together with a very bad angle misalignment. The light may be refracted outside the core. Fiber and rough, irregular. Both of the fiber end is cleaved badly. The rough and irregular end of the fiber caused the light refracted outside the fiber core. 2. Splicing loss. Splice process related parameters are those induced by splicing methods and procedures. The parameters include lateral and angular alignment, contamination at the fiber end and core deformation due to unoptimized heating and pressing. These external parameters can be controlled and minimized by improving skill of the individual doing splicing and by automated fiber alignment and fusion cycles. It has been observed that splice loss between two identical fibers is as high as 0.04 decibels. This excess loss is due to misalignment and other splicing process parameters. Insertion loss. Other important parameter related to splice loss is fiber end angle. Proper fiber end preparation is the most fundamental step to get acceptable splice loss. Generally, end angle less than 2 degrees gives acceptable field splice loss. End angle is dependent on condition of cleaver and cleaver blade. Typical end angle of well-maintained cleaver is around 1/2 degree. It has been observed that these parameters can give splice loss as high as 0.4 decibels. By controlling these parameters, acceptable field splice loss can be achieved. 3. Connector loss. Occur due to the bad condition of the connector. FCLC, street, FDDI, such A. Dirt and dust around core. B. Core fiber defect.